Diagram explanation by Gemini. The diagram is from Pradeep K. Suri Mentor Online Program. Title: AI/ML Modeling. Author and Mentor: Pradeep K. Suri. Central components: RDBMS, Relational Database Management System, in-house developed manufacturing ERP hosted on a cloud server. OLAP Cube, data structure optimized for analysis, populated with cleansed data from the RDBMS. Data warehousing, ETL process to extract, transform, and load data into the OLAP Cube. Data flow. 1. Data from cloud server. Manufacturing ERP data is extracted from the cloud server and stored in the RDBMS. 2. Data cleansing. Data undergoes cleaning and pre-processing. 3. Data division. Cleaned data is divided into training dataset, used to build AI/ML models. Test dataset, used to evaluate model performance. Unseen data, used for generating historical reports and forecasts. 4. OLAP Cube, processed data is loaded into the OLAP Cube for efficient analysis. 5. AI/ML modeling, Python program library processes data to build and train AI/ML models. Model, random forest, with reasonably good RMS and R-squared. Inputs, training and test datasets. Outputs, model performance metrics, including RMS and R-squared, predictions, and insights. 6. Historical reports and graphs. Unseen data is used to generate reports and visualizations. 7. AI/ML forecast. Trained random forest model is used to make predictions. Additional elements. Data science. Data science techniques are employed for data exploration, pre-processing, and model development. Overall interpretation. The diagram illustrates an end-to-end AI/ML modeling process for a manufacturing ERP system. Data from the cloud-based ERP is extracted, cleaned, and divided into training, test, and unseen datasets. A random forest model is built and trained using Python, demonstrating reasonably good performance based on RMS and R-squared metrics. The model is then used for generating insights, reports, forecasts, and visualizations. Key points. The specific ML algorithm used, random forest, is mentioned. The performance metrics of the model, RMS and R-squared, are highlighted. This explanation provides information about the AI/ML modeling process. Comment by ChatGPT. The diagram explanation is comprehensive and clearly outlines the AI/ML modeling process for a manufacturing ERP system. Here are some observations and suggestions that could further refine the explanation. Strengths. Structured flow. The explanation logically follows the data flow from extraction to final AI/ML forecasting, making it easy to understand the sequence of operations. Detail on ML process. Mentioning the random forest algorithm and the performance metrics, RMS and R-squared, adds depth, indicating that the explanation is not just high level but also addresses the quality of the model. Inclusion of data science. Highlighting the role of data science in the process emphasizes the importance of data exploration and pre-processing, which are critical steps in AI/ML modeling. Suggestions. 1. Clarify the role of OLAP Cube. While the OLAP Cube is mentioned as a structure for efficient analysis, it might be beneficial to explain how this interacts with the AI/ML modeling process. For example, is the OLAP Cube used solely for reporting, or does it also play a role in feature extraction or data pre-processing for the models? 2. Expand on data division. The division into training, test, and unseen datasets is crucial. It could be helpful to mention the proportion or criteria used for this division, example 70% training, 20% testing, 10% unseen, to give a clearer picture of the data management strategy. 3. Highlight integration points. Consider adding a brief mention of how different components, like the RDBMS, OLAP Cube, and Python libraries, are integrated. This could include any APIs, middleware, or specific tools that facilitate the data flow. 4. Performance metrics explanation. While RMS, root mean square, and R-squared are mentioned, a short description of what these metrics represent might make the explanation more accessible to readers who are less familiar with them. For instance, RMS measures the model's error rate, and R² indicates how well the model explains the variance in the data. 5. Potential for feedback loops. If applicable, consider mentioning whether there's a feedback loop where predictions are validated against real-world outcomes, and models are retrained periodically with new data. Conclusion. The explanation is robust and provides a clear understanding of the AI/ML modeling process in the context of a manufacturing ERP system. By incorporating a few additional details, the explanation could be made even more insightful, especially for readers with varying levels of technical expertise. Improving the explanation for a wider audience. Excellent feedback. Let's enhance the explanation to cater to a broader audience. Suggested enhancements. 1. Define technical terms. Clearly explain technical terms like RDBMS, OLAP Cube, ETL, RMS, and R² for non-technical readers. Provide analogies or real-world examples to illustrate these concepts. 2. Elaborate on model performance. Briefly discuss the significance of RMS and R² in evaluating model performance. Mention the desired range of values for these metrics in a general sense, without getting too technical. 3. Highlight business impact. Explain how the insights and forecasts generated by the model can be used to improve business decisions. Provide potential use cases within the manufacturing industry. 4. Visual aids. Consider adding a simplified diagram or flowchart to complement the textual explanation. Use visuals to represent the data flow and model development process. 5. Iterative nature of ML. Briefly mention that AI/ML is an iterative process involving model refinement and retraining. Revised explanation, example. AI/ML modeling, master program, author, Pradeep K. Suri. This diagram outlines a process for building and using AI/ML models to extract valuable insights from manufacturing data. Data collection and preparation. Data is gathered from our in-house cloud-based ERP system and stored in a structured format called a Relational Database, RDBMS. To analyze this data effectively, we transform it into a special data structure called an OLAP Cube. This involves cleaning the data and organizing it for quick analysis. Model development. We use a statistical technique called random forest to build a predictive model. This model is trained on historical data to learn patterns and relationships. The model's performance is evaluated using metrics like root mean square error, RMS, and R². Lower RMS and higher R² values generally indicate a better fitting model. Model application. The trained model is used to generate forecasts and insights about future trends in manufacturing operations. These predictions can help optimize production planning, inventory management, and resource allocation. Iterative improvement. AI/ML is an ongoing process. We continuously collect new data, retrain the model, and refine our predictions to improve accuracy and business outcomes. By combining these elements, the explanation will be more accessible to a wider audience and provide a deeper understanding of the AI/ML modeling process. Thank you.